Okay, for our next topic, what we're going to talk about is frequency tables. But before we get to frequency tables, I want to talk just a tiny bit about gathering data. I've talked before about if you were in a face-to-face class with me, I would have done this, and if you were in a face-to-face class with me, I would have done that. So if we were in a face-to-face class, one of my favorite activities to do here is to gather a little bit of data from you guys, just to make sure that you see how the data gathering process would go with something a little more physical and you can be active with it and part of it. And then we'll do a lot of work using the data that we gather, and I'm actually going to use a previous class's worth of data since I can't see you guys face to face, but I'm going to show you how it would be done. So this first stack here, these are called unifix cubes, and they're all snapped together. Sometimes they're called snap cubes. And I'm going to use them as a measuring tool. So if I was measuring tomatoes, like we've talked about before, I might measure the weight, but I might want to know how tall or how wide or something like that. So there's some standard units that we use there, like inches or centimeters or whatever. For these, we're going to use these snap cubes as our measurement unit. And so we're going to say how many snap cubes, or how many of these large cubes is it. And I've done different things in classes. Sometimes we measure hands, sometimes we measure feet, sometimes we figure out how far across your forehead is, you know, just different things that we can measure inside of a class. So today, because I'm kind of limited, I'm going to measure hands. And what I want to know is how many snap cubes long is a hand, or your hand, or my hand, or whatever. And so before we do this, we have to get a little bit of a definition going here. So for instance, am I allowed to use the total length of my hand, including the fingernails, if we want to know how long my hand is? Okay, and in my head I hear you saying, no, of course not, that's not part of your actual hand. So I can't go all the way to the tips of my fingernails, I've got to go to the tips of my hands. And so different people have different kinds of hands going on, okay? If you're not sure, look at yours and look at a couple of buddies or some of your family members and see. But different people have different longest finger, okay? So some people it might be the pointer finger, some people, mine is clearly my middle finger is the longest. Some people it might be the ring finger, and I think that has to do with genetics and dominance and this and that, whatever. But look around you a little bit, talk to some of your family and friends, whatever, and figure out, oh, who has which finger is your longest finger, or toes? That's an interesting thing, because sometimes it's your big toe is the longest, but for some people it's the second toe, like the pointer toe, basically next to the big toe. So it's kind of interesting, something to play with if you have a little bit of extra time. But for our purposes, of course, we're only going to go to the tips of whichever the longest finger is for you. And I usually say, well, how far down do I come? Most people want to go past the palm. So most people have some kind of a little crease right here, or it's the end of your bump there for your palm. So we would normally say we're going to go to the end of the palm or to that crease, depending on what you've got, okay? Depending on how your hand works out. And you want it to be as flat as possible. So I'm looking at mine, and I'm saying, okay, I've got it lined up down here at the bottom. So I'm going to look up here at the top. Sorry, I don't have much space. And I'm looking at mine, and I'm saying, well, mine doesn't fit exactly on a cube, right? It's a little bit longer than that. It's not as long as this last cube. So what do I do? And most people would come up with, well, maybe we could do standard rounding measurements. So for me, I'm looking at, is this half of this cube or not, or more? And the answer is no. I don't go to the halfway mark there. So I'm not going to count that last cube. So I'm actually going to take that cube off, okay? So we would say that this stack of cubes represents, as well as I can, the length of my hand. Now we know that my finger is a little bit longer than this, so I'm actually rounding down, okay? So some people, if your finger was a little bit past the midway point of the next one, you might round up. So there are rounding rules in place, and that might make a difference as far as what we're doing here. But for me, I'm going to say this represents, as close as I can get it, the length of my hand. So 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes. That's 9 of the large cubes. That's what I'm going to say for my particular hand measurement. Okay? And so I have the measurements, like I said, from another class. I'll show those to you in a second. But that's what we would do. And then, as a starting point for these little cubes, because they don't stick together as well, see, that one just fell apart. For these little cubes, I would start with something as close as we can possibly get to the long cubes, because that at least gives me starting point. But we know what, and try to line them up at the end, at the bottom, so that we have the same starting and ending point. But we know my hand is actually a little bit longer than this, right, because I rounded down. So we're going to have to see, oh, do I need an extra cube in here, basically, and I want to snap them together as close as I can get them, not have that gap that was sitting there if you didn't see it. Keeps on pulling apart. Okay, so now I'm going to try to measure against my hand again, and again I'll try to line it up as close as I can to there. Get as straight as I can here. Try to pull my palm up so that it's right there at the bottom of my palm, straight as I can do. And look, yeah, my hand's definitely longer than this guy is, right? Let me bounce this up a little bit so it's even with the end of my palm. So I definitely need at least one more cube to make this as long as my hand. Okay, and I'm going to snap those together in a second, but I don't think I need an extra cube, right? Just one extra cube here, one more cube. So what looked, and that looks pretty stinking close, right? So that's pretty good estimate. So what looked like it was lining up well with that actually is a little bit short, so I need that extra small cube here. So I'm going to count that up, and that's going to be in my measurements as well. So how many cubes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so I've got 18 of these little cubes in there. So that's what I'm going to use for my measurement. Okay, so then what? All right. Then, if we were in class, I would wander around class and I would say, okay, let me ask you for a measurement, and I'm going to use a little bit more mathy terminology here now. So, if I ask you, if everybody has measured their hands, and then I ask you as a class and I say, how many of you have so many large cubes as your estimate for your hand length? That's the question, right? Hand length. All right. Well, unless we have babies in the class or small kids, we're probably not going to have, because these were the large cubes, right? We're probably not going to have 1 or 2 or 3 or 4. I've never had anybody that was a 4 in one of my classes with adult people in them, which by adults I would say anybody over, say, 14, right? I know that if you're 14, you may not be considered an adult, but you're probably pretty close to actually full grown, right? So you're probably not going to have a kid-sized hand anymore. So probably not 4. I have had before in one of my classes somebody who had a 5 for their large cubes, and she was a small, little dainty girl, and she had a really small hand. So I have had that, but I usually do have a couple of 6s. Okay, so I've grabbed some data, and I'll show you. And then the rest of those, of course, I usually have some of those. And then there's a certain amount that you would say that's the most that you're going to get. And then after that, like maybe guys a lot of times have really big hands, or sometimes girls who play basketball, if they're really tall or something like that, they might have big hands. Some of my volleyball girls might have big hands. But then past a point, that's like the most of those you're going to get, unless what? Maybe we invited some professional basketball player to come in, you know. If we had a really tall professional basketball with a really big hand span, they might have a really long string of these cubes representing their length of their hand, okay? So beyond a certain point, you're probably not going to get that unless you have, like I said, some of those really professional basketball kind of players in the room. And how often does that happen? Like, I'm not seeing Michael Jordan or Shaquille O'Neal or LeBron James, any of those people coming into my classroom, so it's probably not happening. Okay, so let's get back to the mathy terms. If I say to you, how many of you have, let's just say 5 large cubes as your estimate for your hand length, and then you guys respond back, then I am asking you 5 large cubes, okay? And the number of large cubes is predetermined, let's say preset, by me. You cannot control it. Okay. However, I, the researcher, independently asked for it. Okay. I could have said, how many of you have 5 large cubes? How many of you have 7 large cubes? I could have picked any number I wanted. So I, the researcher, am the one who's picking that as my independent variable. That's what that's going to be called. It's an independent variable, because I got to choose it. Okay. Now, once I have chosen what my independent variable is, you guys, as I'm calling out, how many of you have 5 large cubes? You don't have a choice. Okay. The number of people who raise their hands depends on the number of cubes I call out. Okay, so in other words, if I said, how many of you have 4 large cubes, probably nobody in the room would raise their hand, right? So out beside 4 large cubes, I'd say nobody raised their hand. That's a 0, okay? But for that one little girl in my class, she wasn't a little girl as in a child. She was just really short and really small hands. She had a 5. So she would, if I said, how many of you have 5 cubes, she would be forced to raise her hand, and she can't lie to me, right? Hopefully. Okay, so unless she's willing to lie to me, she's going to be forced to raise her hand because her answer depends on the number of cubes I called out. Okay, hope that makes sense. So in statistics and in math in general, you've probably seen this in an algebra class, that's called a dependent variable. In algebra, a lot of times, we would call the independent variable an x. Okay, a lot of times in algebra, maybe a t, something like that. And the dependent variable is normally in algebra your y variable, or sometimes we say f of x to determine that it's the output. It's the output that comes along whenever I put in this input. Okay, so those are independent variables and dependent variables. So just kind of keep that in mind as we go through. So whenever I finish calling out how many of you have this many, how many of you have that many, maybe this is what it looks like. On the left hand side, I've got the length of your hand in large cubes. 6 was the smallest for this particular class, 7, 8, 9, 10, and I didn't have anybody who had an 11, so I put a 0 there to kind of hold the place. But I did have some 12s, and I did have a 13, one person with a 13. So I can't just say, oh, stop here because I got a 0. I got to keep going until everybody in the class is accounted for. Okay, so this, what I've got made here would be what would be called a frequency chart or a frequency table. Okay, so back to the topic at hand, right? Okay, the only thing I might be missing as far as just a regular old frequency table, and there's other stuff that happens, and I'll talk about those in a minute, but the only thing I might be missing is a total. So a lot of times it's helpful whenever I go to do percentages and stuff like that later, okay, if I have a total for how many people were in this class. So real quickly, I've got 12, and 5 is 17, and 4 is 21. Please check my math. 21, 22, 23, 24. I believe there were 24 people in this class. Okay, so double check. That's 10, 17, 21, 22, 23, 24. I'd hate to make a mistake on this video and have to go back and correct it. Okay, so that's what that would look like. But this is a frequency table, and basically it just tells me how many people have this many large snap cubes as their hand measurement. Okay, and then we would do the same thing for the small guys. So I think mine was an 18, if you remember. Okay, so we have everybody have an approximation for that, and then we go from there. So let me grab that data. I didn't write that down on this piece of paper. Let me grab that data from my other thing. So for our class, we had 14. Let me find, yeah, I'll just put it here. 14 snap cubes, we had 1 person. 15 snap cubes, we had 2 people. 16, we had, let's see, that was 2 people. 17, we actually didn't have anybody there. 18, we had, let me see what that was. That was 5 people. 19, we had 5 people. And 20 was a 3. 20 was a 3. There was no 21s. 22. There were 2 of those. Okay. 23 was a 1. And 24 was a 0. I'm going to have to come over here. I'm sorry. And 25. Let me make sure my numbers are adding up. Sorry. 1, 2 of those. 26 is 1. The problem with doing this in class is that sometimes people add in, sometimes I have to do this multiple times. Like I'll add up and I had 24 people for the large cubes, and so I'll say, okay, and then I do the small cubes and I only have 20 people in the small cubes, and I'll be like, okay, who didn't vote? You know, so if you didn't vote, then we got a problem. So let's just double check my numbers real quickly and make sure this works. This is 5, 10, 15, that's 21, 2, 3, 4, so that is also 24. So yes, this is the same class worth of people, okay? So in my table, I just kind of went over there. We'll make a new one and it'll be okay. All right, so what does frequency mean in the case of our statistics class? That's the question that we're probably wondering. So frequency in our case is just how often something occurs. Okay, so a frequency table shows the number of times or we'll call that the frequency, a data point occurs. So here's the question. As I'm gathering up all this data, is it okay if I say, okay, Susie, you had a size 6 large cube hand. Oh, Mary, you had a size 6 also. Well, I've already got a size 6, so I'm just going to not record you, Mary. No, of course that's not okay. Every person in the room needs to have a vote, so to speak, or a say. We need to have something that represents the entire group. Or if this was a sample, instead of a census. In my class, it's always a census, right? Because I've only got maybe 30 students in a classroom. But if it was a sample, then whatever my sample size is, every subject or every participant in my sample needs to get a vote, so to speak. They need to be counted. So I need to make sure I've got a measurement for everybody, okay? So frequencies table just shows me the number of times or how often or however you want to think about that a data point occurs. In this case, we're talking about number of cubes, right? That's my data point. How many of you have six large cubes? And the data point there happens twice. There are 2 people in my classroom who have a size 6 hand, okay? So the frequency table just basically has two columns on it. It's going to be the category of the data, and then it's going to be the frequency of the data. So we're going to give the characteristic. So what does a frequency table look like? We're going to give the characteristic of the data. Some books call that the category. Okay, and then over here we're going to call it the frequency of that characteristic. How many times did that thing happen? Okay, and this is a basic frequency chart or table, and a lot of times we just stop there. However, there's some other stuff that happens, so I want to talk about those things, and then we'll create one and make sure we're all on the same page. So one thing is a relative frequency. Okay, so what the heck is that? That's what we want to know, right? And the other one is called the cumulative frequency. And again, some frequency charts have all of these things, some only have some of these things, and we'll go from there. So what the heck is a relative frequency? Well, let's see. Relative means what? Not your parent or your sister or something, not that kind of relative. Relative in math, right? Something is relative to something else, right? So we compare. Relative normally means compared to something. So in this case, what we're talking about is what portion of the total do we have here, or what percentage? So portion or percentage of the entire group. Okay, so for our purposes, let me just fill in one little bit here, and we'll do the whole table. If we had said 6 cubes, and Susie and Mary both said, oh, I have 6 cubes, and that's frequency for 6 cubes is 2, okay? But then I need to talk about the portion or the percentage, so the relative, relate that back to the entire group, right? So the whole. So 2 out of, in this case, I had 24 people in my group, in my classroom, right? So 2 out of 24. So there's a couple of things you can do with that, and related back to previous sections, this is a fraction, okay? As far as I'm concerned, fractions are okay. I'd actually want that to be a reduced fraction. So if you were giving it to me in fractions, well, sometimes a not reduced fraction is okay, and here's why. If I then later do more math, and I have a bunch of 24s in the denominators, and I have reduced this one to 1/12, then sometimes that'll be a sticking point, because if I need to add them back together or something like that, oh, all of a sudden I've got an issue. So in statistics, a lot of times we are okay if you leave something in a not reduced fraction. If you go ahead and reduce it, that is mathematically the best answer, would be the reduced fraction portion. But in statistics, and I'll show you what I mean in a minute, in statistics, a lot of times we will not reduce those. So just be aware that that's out there, and don't be freaked out if I give you a not reduced fraction, okay? So I'm good with fractions, and if you're good with fractions, just leave them alone, okay? But some people don't like fractions, or there are some times, some applications where we won't want a fraction, and people might like decimals or percentages or whatever. So we've already covered in this course how to convert back and forth, right? So how would you convert this to a decimal? How would you convert this to a percentage? Be ready to do those kinds of things as you move forward. We're going to be a lot more math and a lot less writing in this portion of the course, so be prepared. All right, so that's what a relative frequency is. It's comparing your frequency. Okay, hang on. Let me give you a definition. Sorry. Okay. A relative frequency compares a given frequency to the total group. Okay, so it's a proportion or percentage. Okay, and often it looks like the given frequency on top of that characteristic that I'm after, whatever it was. In this case, that characteristic was, how many of you have 6 snap cubes for your measurement? And then the total number of data points gathered. Okay, so in our case here, it's 2 people had 6, 24 people were measured. All right, so that's kind of some definition-y stuff for relative frequency. And then the last one here is cumulative frequency. So let's just talk about cumulative real quickly. Cumulative, think about ice or snow or accumulated rainwater or something like that. Cumulative means how does it accumulate as we go? So what does that mean? I'm using the same word to define itself. So how much do I gather as I go? Okay, so if I was looking at this as, for instance, accumulating people as I go here, well, how many of you have 6 or fewer cubes? That would just be 2, right? But then I can accumulate, I can gather in more if I say, how many of you have 7 or fewer cubes? Okay, well now that would include the 6 and the people who have 7, right? So it would be 2 plus 3. So if I said, how many of you have 7 or fewer cubes here? You would say there are 5 people in that class, right? And then if I said, well, how many had 8 or fewer? Well, that was 2 plus 3 plus 5. So I'm gathering more and more. I'm summing up or I'm totaling up as I get more and more of them. So it's accumulating. That's why we use that word. Okay. So basically we call it a sum of frequencies that meet a certain threshold. Actually, I should have put this on the next page. So, for instance, 7 or fewer cubes. Okay, in that case, and it's a cumulative frequency, I would have said, well, that was 2 plus 3 for the 7, right? Oh, I'm sorry. Let me keep this up. This is the same guy. For the 6, there were only 2, right? So there are 2 occurrences that are 6 or fewer. So I'll make sure this looks like the correct line here. Okay. Now, what should happen as I go along? Okay, for the 7, there were 3. For the 8, it was 2 plus 3 plus 5. So this would be 2 plus 3. 2 plus 3 plus 5. That's 10. I haven't done this math yet, so this would be 2 plus 3 plus 5 plus 7, which is 10 plus 7 is 17. This is 17 from above, right? Plus these 4, which is 21. This is the 21 from above plus the 0 that were 11 of them, I get 21. So notice that there's no more accumulation here because there was a 0. So I didn't add 2. I didn't sum more stuff in there. But it never goes down. So this is what I was asking. What happens as I go farther down my frequency table? Well, this was a 2. This is a 2 plus 3. 2 plus 3 plus 5. It's this continued summation going on. And so it always gets bigger, right? And you know you've done it right if, what? When I get to the largest possible value, all of my data points should be represented, right? So here I've got 12. There were 2 of those, so it was the 21 before plus 2. That gives me 23. For the very last guy here, I know it was all the ones that came before, so 23, plus the 1 that was here, that's 24. So the accumulated number, or the cumulative frequency, when I get to the very bottom of my frequency table is 24. Well, that's what? That's the same as my total. Oh, yeah. So I know I've done it correctly if my final accumulated frequency here is the same as my total, because that means I got all of my data points represented in there. So I'm good. Okay, so that's awesome. I like that. All right, so I probably need a cumulative frequency definition. A cumulative frequency is the sum of all the frequencies preceding the given data point, given category, let's say that, plus the frequencies in that category. Okay, so what the heck does that mean? Again, if I was looking at, let's say 9 here, if I wanted the cumulative frequency for 9, it would be the sum of all the previous guys plus the occurrences that are in that category, so for the 9 in this case. So all the guys before it, 2 plus 3 plus 5 plus 7, that gives me, so all the guys before it plus the one I'm in, that gives me the total accumulated stuff. Okay, awesome. All right, so that's the idea behind the frequency tables. That gives you a good idea of what's going on. I'm going to actually go ahead and create with you now an entire frequency table. So we're going to do all of the categories, in other words, using this data right here for the little guys, and then for the big ones, and then we'll talk about little ones. Or actually, I can leave that for you to do on your own so that you can figure that out. So let's see. Okay, length of hand. Let me get rid of this. Length of hand in large cubes. Okay. The frequency, so that's the number of people who have that measurement. The relative frequency, we're going to do all of these categories. And the cumulative frequency. Now, like I said, we don't always do all 4 categories, and a lot of the frequency tables you've seen actually probably in an algebra class. It looks like an XY T-chart, right? So you would have your independent variable and your dependent variable, and that would be it. So we already should be pretty familiar with frequency tables. We just may not have called it a frequency table. It might have been a T-chart or something like that, or an XY chart or something. So the full frequency table includes these last 2 categories, or the last 2 columns, but we're not always going to use those. So the first part's easy. We had 6 cubes, 7 cubes, 8 cubes, 9 cubes, 10 cubes, 11 cubes. I need a little bit more space here. 12 and 13. Okay. And then the frequency was given. 2 people said they had 6. 3 people have said they had 7. 5. 7 had 9. 4 had 10. There weren't any 11s in the class. There were 2 12s and 1 13. Okay. So then we have to do a little math, so to speak. And if you have lined notebook paper, you'll be fine. I find that it can get a little bit confusing following all this stuff across. So I'm just going to put lines on mine. If you have lines already, great. Okay. So a little bit of math. So we need a percentage here, or a proportion. So I am going to just do the fractions because I didn't bother to bring a calculator with me to this. I'm sorry. But again, if you want to go ahead and change those to decimals or change those to percentages, then fine. I'm going to almost always, there are a couple of cases where I'll need a percentage or something, but I'm going to almost always leave mine as a relative frequency as a fraction. Okay, so 2 out of 24. For 7 cubes, there were 3 people, and the total was 24. So that's 3 out of 24. Does that make sense? Okay. For 8 cubes, there were 5 people who said they had that. So the total measurement for this is 5 people out of 24 in the total. So 5 24ths. For 9 cubes, there were 7, and I have 7 out of 24. Notice, by the way, 7 out of 24, that's going to be an ugly decimal, so there's not really any reason to change it unless you just want to. For 10 cubes, I had 4. And that's 4 out of 24. Now that one will reduce very nicely. So if you wanted to, you could call this 1/6, right? But I'm going to show you why sometimes, I mentioned earlier, sometimes in statistics we don't want to do that. And I'll show you why in just a second. Okay. For 11 cubes, there were 0 people, so that's 0 out of 24 or 0. You can always reduce a fraction with a 0 on top to just 0. Okay, and for 12, that's 2 out of 24. And again, we know that that's the same as 1 out of 12, just like this one was 1 out of 12, this one was 1 out of 8. But I'm not always going to reduce, and I'll show you why. And this one person had 13 cubes, and that was out of 24 total. Okay, so I'm going to show you a quick trick for checking yourself. If you want to make sure you have your relative frequencies correct, then add these up. Okay. How much should I have? Just like here, your frequency, if you have them all, the total should be 24. Okay. Well, here, if I've done it correctly, if I got the right fractions, right, then what should this be? This is relative to the whole, right? So if it's relative to the entire group, or the entire class in this case, then this should add up to what? A 1, a whole. So this should be 24 out of 24. One whole group here. So I can check real quickly if I leave my fractions all with denominators of 24. Okay. If I change this one to a 1/6, and this one to a 1/12, and this one to 1/8, and this one to a 1/12, and then I go to try to add up these fractions over here, it's not so easy, right? Because I've converted them into a reduced fraction, and I would need to make them a common denominator again to be able to add them up quickly. But if I left them all with the same denominator, then now whenever I come back and I want to mess with them, it's pretty easy, right? I just need to make sure it all adds up to 24 over 24. So 2 of those. And they have the same denominator, so we just add the tops and keep the bottom the same, right? So 2 of those, 3 of those, 5 of those, that's 10, and 7 is 17, and 4 is 21. There's none of those, 22, 23, 24 24ths. So indeed, I do have 24 24ths. So sometimes it's easier to just leave this fraction alone. And we'll actually see that whenever we get into probability. And sometimes we just don't want to reduce those. So I am good for this stats course if you leave your fractions not reduced. Leave them as a fraction, leave them not reduced. I'm okay. Now, if you want to go ahead and reduce because it's been drilled into you, it's ingrained, it's okay. I understand that 2/24 is the same as 1/12, and I can make that conversion. And if that's the answer you gave me, you're going to be fine. Okay. All right. What about cumulative frequency? Okay. Now, my problem with these frequency tables is that they stick this fraction thing right in the middle, and I don't need it, right? So remember that the cumulative frequency is based off of the regular frequency. So even you could like fold this over or something so you don't even have to look at the relative frequency. Or I have seen people who put their relative frequency at the very, very end so they don't have to mess with it. But so this one, the first one's just 2, right? And then this one's 2 plus 3, which is 5. And we already did this, but just so you know, 2 plus 3 plus 5, that was 10. 2 plus 3 plus 5 plus 7, that's 17. I'll do it out, the actual math here so we can see it. 2 plus 3 plus 5 plus 7 plus 4, that was 21. 2 plus 3 plus 5 plus 7 plus 4 plus 0, still 21. 2 plus 3 plus 5 plus 7 plus 4 plus 0 plus 2. Remember, I'm adding all the frequencies before it plus the category that I'm in. Plus the 2, that's 23. It's an equal sign there. And 2 plus 3 plus 5 plus 7 plus 4 plus 0 plus 2 plus this 1 that's in this last category, that's 24. Okay, so again, my cumulative frequencies are the sums of those frequencies. So the total again there is 24. All right. So that's what that looks like. The only thing that's left that I haven't talked to you about that kind of has to do with frequency tables, and we'll see it as we go along. I'll just give you one really quick example. If we were talking about, and in fact, I think I'll just show you the example instead of me writing it up. If we were talking about exam grades, and what something's happening in the exam grades, there's something called binning. Sometimes we bin our data. Okay? And people say, what the heck is that? Okay, so when you're binning your data, basically I tell people it's like you have, it's an old-fashioned basket, a bin, right? A trash bin, or a crisper out of your refrigerator. Sometimes, you know, the older generation might call that the bin, that's in B-I-N. So a waste basket, a trash can could be a trash bin. So garbage bin for garbage disposal, stuff like that. So basically, you dump things into a bin. Dump things into a bin is the way I think about it. Okay, so for our cases, for data, that means we group our data. Okay, so in other words, here we were talking about people in each individual category, people with 6 cubes, people with 7 cubes, but I could have grouped them, say, by 2. People with 6 or 7, so I could have one group that had 6 to 7 in it and group them together, and that would have had 5 people in it. I could have one group that's 8 to 9, and you guys have 8 to 9 cubes, so that's 5 plus 7, 12 of those. Okay, so I could have done that. It doesn't really make sense there, but sometimes where it makes sense is whenever you're talking about test scores or something like that. So here's just a nice, lovely example that I'm going to hold up here to show you so I don't have to do this myself. Okay, so if you read this, this says it's a frequency table for binned exam grades, and the top line says 95 to 99. So anybody who made from a 95 to a 99, basically they're grouping them by 5s, right? There was one person. There were a total of 20 people in this class at the bottom of the frequency. So one person had 95 to 99. So the relative frequency there is 1 out of 20. They've got a fraction there, or a decimal. And the cumulative frequency was just 1. Then what about people who scored from a 90 to 94? Well, honestly, in my test, I don't bin this way, I don't group this way. I would have said 90 to a 99, but they're just trying to make more categories, more groupings here. So 90 to 94, they had 2 of those people. That's 2 out of 20. That gives you relative frequency. But for the cumulative, I had the one before plus these 2. 1 plus 2 is 3. Okay. 85 to 89, there were 3 of those. That's 3 out of 20. We've got a 1 plus 2 plus 3. That gives us the 6. 80 to 84, they're saying there were 3 of those. That's 3 out of 20 for the relative frequency. Again, that's the number in the frequency divided by the total. That's how they're getting their relative frequency. Add them all up, 3 plus 3 plus 2 plus 1, that's a 9. This one has the most, 75 to 79. There were 7 of those people. That's 7 out of 20. And added all of those up, that's a cumulative of 16. So interestingly, in this particular class, the lowest score range is 70 to 74, and that is all 20 of them, right? So 4 out of 20 made it 70 to a 74, and then that gives me all 20 of them. So if the class is 20 people, which I assume it is because that's how many are in my frequency table, then everybody made a 70 or above. So basically everybody passed this particular exam, right? All right, so that's the only little thing, and it's just, we don't do that a ton, so I'm not too stressed out about that particular example, but I wanted to make sure you've at least seen binning because there will probably be some of that in your homework. All right, thanks. I'll talk to you later. Let me know if you have questions.